Hello, everybody, and welcome to our What's New in SAP HANA Cloud webinar. My name is Thomas Hammer, Lead Product Manager for SAP HANA Cloud, and I'm super happy to welcome you to this time's episode about specifically the Q4 innovations that have been introduced to SAP HANA Cloud already. And as every time, we want to give you some insights into these innovations. We will highlight a few of them. Unfortunately, we can't cover all of the great features and enhancements that have been introduced to SAP HANA Cloud, just for the sake of shortening this to the most important content. We have picked our highlights, but definitely you should not miss out on following up on all the details. But later on, we will talk about that on how you can do that most efficiently with the resources that we have provided with the release. Before taking a look at the contents, I want to highlight that there is a bunch of product managers sitting in the backend and supporting for Q&A. So as always, you have the possibility to share your questions with us, and we will do our best to also respond to those questions properly. Now, you can see the product managers with their areas of expertise already here on the screen, and that kind of gives an indicator of what we will be covering in today's session. Today, we will first of all talk about a few general enhancements, and I will go into the details myself, talking about the improvements to workload management in HANA Cloud, to the new capabilities with regards to our alerts and metrics API access service, and we will also cover briefly the innovations introduced into calculation view modeling. Later on, we will dive deeper into the innovations specifically related to our data lake in SAP HANA Cloud, and I'm proud to have Jason Hinsberger, our product expert for the data lake, with us covering those topics. And then the next section is precisely about the SAP HANA Cloud, SAP HANA database. And here, some of our product experts will guide us through innovations in the various areas, specifically talking about artificial intelligence and the innovations in the area of our predictive analysis library. We will talk more about the enhancements in the area of multi-model data processing, followed by enhancements with regards to our multi-environment support, sorry for that. And later, we will also take a look at database development and innovations in the area of HDI. Without further ado, let's directly jump into the first section, which is our general update. So a few things that I definitely want to mention before we dive into the specific sections are, for instance, the improvements to workload management in HANA Cloud. We have introduced with the Q4 release of SAP HANA Cloud a new parameter, which is a so-called CPU threshold that helps to avoid underutilization of SAP HANA database systems in SAP HANA Cloud. And with that parameter, which is enabled by default for all systems running on QRC4, either being newly created or being upgraded to QRC4, we ensure that a certain utilization of the system is always present, and workload classes are only kicking in and are only active if that certain degree of utilization is reached. By default, it's set to 50%. So basically, if CPU is not utilized up to 50%, no workload classes are being applied. But apart from that, we are for sure applying the ordinary workload management concepts. Administrators can change this threshold accordingly, as described here on the slide, but you definitely should be aware that it is now coming up with QRC4, and I think it's a great improvement as we make sure that you can truly utilize all the capacities you have available with your HANA database system in HANA Cloud. The next innovation that I briefly want to highlight is an innovation with regards to our alerts and metrics API. Now, with the Q4 release of SAP HANA Cloud, we give you the capability to access alerts and metrics for multiple instances in SAP HANA Cloud and not just for a single one. And that is possible via our new access to the alerts via the so-called service plan admin API access. And this service plan and the APIs associated give you the possibility to retrieve administrative KPIs from multiple instances, as stated earlier, at one time. So for instance, you can access the CPU utilization as a good example, referring to the earlier case for multiple systems, or even get insights into long-running statements, which in many cases is very beneficial to know about for multiple instances. And if you want to deep dive into specifically this innovation, we have a tutorial prepared that guides you through the steps of how you can make use of these great enhancements in the area of our metrics APIs. And last but not least, the last topic, which I briefly want to touch on before we dive into the deep dives with our product experts, is the area of calculation view modeling. This time, we're not going into all of the details with regards to calculation view modeling, but with every release of HANA Cloud, there is a great set of innovations specifically introduced in that area of the product. Here on the screen, you can only see 4 innovations highlighted, but there is much more, and I just want to mention the blog post being created by our product expert, Jan Zwickel, who's responsible for calculation view modeling, who will go into all the details with regards to these capabilities. All that being said, I'm basically handing the stage over to Jason Hinsberger, who is now going deeper into the innovations associated with our data lake in HANA Cloud, being one of the 2 very important service components of SAP HANA Cloud. Jason, with that, over to you. Stage is yours.
Thanks, Thomas. Hello, everyone. I'm just going to share my screen here. Make sure I get the right one. Thomas, if you could just verify when you can see my screen.
I can see it properly. Thank you, Jason.
Perfect. Thanks. Okay, so just a couple of new features I wanted to highlight for the data lake that are very commonly used features that have some nice improvements made to them. So first of all, we now support the use of a PSE, so you can store credential information independent of statements in the data lake. So very similar, well, actually following the syntax that you have on the HANA database side, you can create a PSE and include certificate information in it, and then use those credentials to execute load, unload type statements. So to this point, every time you execute load table or unload table, if you're targeting an S3 bucket or an HDL files bucket, you had to specify the full connection information in the actual load statement. Obviously, this is not ideal since if you need to renew a certificate, if any of the connection options change, you have to update every single statement that uses those credentials. So now you can create a credential in the database and simply refer to it in the load statements, which makes it obviously much easier to manage those credentials. Second feature, which is closely related to this, is using a load and unload table. You can now import and export from any HANA Cloud Data Lake Files endpoint. So before the QRC4 release, whenever you create a data lake, you always get a data lake files and optionally a relational engine, and the 2 are by default connected to each other. Now the additional functionality is there that if you have a relational engine instance and then you have data lake files instance running separately somewhere else, you can use that data lake files instance to load and unload data into your relational engine separate instance. And of course, there's new connection string options that allow you to specify the full data lake files endpoint and certificate information. But you can also leverage this new PSE support that I just mentioned to do that as well. So I just have a quick demo to lay this out, and it basically really illustrates the differences. So we're not going to do a big load. I'm just going to use the region table from TBCH. Of course, I have to reconnect to my instance. Create my table. And then now we're just going to execute a load table into that instance into that table from a different instance than the one I'm connected to. So we're specifying the location of that instance via this container endpoint, which you can get again from HANA Cloud Central, and then we're specifying the entire connection information in the statement itself. So I'm giving the endpoint, I'm giving my certificate information, my client certificate and key, and of course the public key for validating the connection endpoints. So pretty lengthy statement, and then the rest of the options. Once I execute this statement, again, you can see how long it is. And you can imagine if you're maintaining a big set of these statements in a script, how unruly it can get, how quickly, how easily you can make, small mistakes, and it can cause lots of issues for maintenance. But everything works. We can load the table, and if I move this up a bit, we'll be able to see, we can see the results. So if instead we want to actually just use credentials to do this, again, as I mentioned, very similar to the HANA syntax. So we can create a PSE. We're going to add the server certificate to validate the connection, and then we're going to add my client certificate and key to the PSE. So there's my key, my certificate, and then the public certificate of the CA authority I created to sign the keys. Once we've got all that done, we're going to create a credential. We're going to say that the credential is for reload and unload. We give it a name, which is this purpose. It's X509. So all the connections to the data lake files are certificate based using X509 certificates that are signed by your CA, and you use them to access using the REST API. So that's fine. So now if we want to load the region table, instead of that giant connection string that we saw before, all we need to specify is the endpoint, so the location of the instance that we want to connect to, and then the name of the credential. So as you can see, much simpler to manage this level of statement than specifying the entire connection string every time. So similarly, you can create PSE or create credentials for accessing your S3 bucket or your Azure bucket or your GCP storage buckets, and leverage them in the exact same way using these statements. Let me switch back. So excuse me. So that is the end of the two little new features that I wanted to highlight. Very useful. And now I'm going to pass it over to Christoph.
Thank you very much, Jason. Let me share my screen. Also, welcome everybody from my side. I'm very pleased to share with you the updates about the enhancements in the area of HANA Cloud AI functions, machine learning capabilities. There's again a rich set of new and enhanced functions. Our kind of highlight feature is a FairML function, which helps our customers to mitigate bias and unfairness in their classification and regression models. You go into more detail for that update. Other updates include a new recommender function, an neural network-based, MLP-based recommender function, which not only allows to make use of historic personal purchase history of customers, but also supporting external feature characteristics about the individuals to be passed into the recommender model. In the area of time series algorithms, there's a series of enhancements. One important one is the external feature importance evaluation capability using a permutation approach supported for a couple of algorithms like the profit implementation, exponential smoothing, and the BSTS time series models. So basically you can evaluate by permutation which of the external features is really important for the time series model predictions. Then the outlier prediction in time series has been enhanced, supporting the massive parallel mode, but also supporting a way to apply multiple outlier scoring methods using a voting approach. Online Bayesian change point detection has been enhanced to support the massive parallel mode to be used by one of our SAP applications soon. And then the AutoML function area in each release adds a couple of enhancements. This time we have an optimized operator selection, new operators for auto exponential smoothing, and feature generation for time series. And then with the Q4 release, there's also a new release of the automated predictive library 2325, which has some customer visible enhancements here in the area of automatic variable selection reports. But now let's look a little bit deeper in the FairML capability. So in classic machine learning models, typically we don't have an automated way to mitigate bias or unfairness related to different minority groups which will be affected by the apply of a machine learning model, so which could be identified by features like gender, race, age, and others. And we've now introduced this new function which overlays in the future multiple PAL algorithms. We start with the hybrid gradient boosting tree models and regression and classification scenarios, where we now can apply different metrics to ensure fairness. One metric would be demographic parity. We want to ensure that the same parity of groups will be selected by the prediction of the model, or that the accuracy should be the same in the model for each of the groups, so equalized odds, or more focused, but similar to equalized odds, or same accuracy, that this should be the case for the true positive rate, so the equal opportunity to be selected by each proportion of the groups, or false positive rate, that each different group identified, for example, by different gender or age group should not be falsely selected as a positive candidate, for example, by a machine learning model. And we will see that in a couple of minutes with a demo, how that applies for a use case scenario. Here's the updated overview of all the HANA Cloud predictive analysis library algorithms. We highlighted in green here what's only available in HANA Cloud compared to previous HANA Cloud releases or SPS 7. So there's a good set of new and enhanced algorithms, specifically in the area of time series forecasting, which are only available with HANA Cloud and the current release, of course. The Python R machine learning client, specifically the Python client, also adds new capabilities. Typically, we add in the Python machine learning client all the new functions released with the previous quarter release of HANA Cloud. So like the quantile transform functions is now available with the 2.19, the Q4 Python machine learning client. However, we are happy that we can at the same time provide the FairML methods within the Python machine learning client, so we can directly try it out in a Jupyter notebook. Similarly to the AutoML enhancements, they're already available with the updated version. And yeah, all the other enhancements, like for example, explainability with the long-time time series forecasting capabilities, is something which we released with the HANA Cloud release in Q3 and is now available in the Q4 release of the Python machine learning client. But now let's switch over to the demo. I'm using here a Jupyter notebook environment, and the example scenario where we want to apply fair machine learning is basically a credit default model. So we want to model customer based on a public available data set, give me some credit, which classifies customers if their loan or credit is likely to become default within the next couple of years or not. And we want to evaluate if there is unfairness in the model. We mean by that a customer is falsely qualified as defaulting his or her credit because, for example, of his age group or his gender. And therefore, we want to mitigate the model in a way that all age groups or all the different genders would be classified the same. So there would no harm be on top of a special minority group within our customer base or customer database. So we're connecting to HANA Cloud using the HANA Python package and are connected to our Q3 system here. And we have previously uploaded the data, put it into HANA Cloud table called credit default FairML. We have a customer ID, different features describing the customer. We have an age group A and B and loan default. And basically what we want to identify and analyze if the age group A and B has an effect on the outcome of the prediction model of the loan default. As you may know, a HANA data frame in Python is simply only a SQL statement. As we can see here, we select top 5 for displaying the top 5 records. For the data frame, we can list the columns. We can use another method called describe. It basically gives us the overview of all the columns and value distributions. One nice info here is that we have no null values in any of the columns, so we can basically go ahead and build a machine learning model. But before we do that, we want to kind of take a look at our target column. So what we want to predict by the machine learning model is the loan default. And we start off by splitting our data into a test data set and a training subset using the test validation split method, and look up our train subset. So that's not 150,000 anymore, but is a smaller group. Our test subset is a little bit smaller. It has about 21,000, 22,000 records. And then we want to basically downsample our training subset for the purpose of illustration here. So both target groups have the same size in our training subset. And now at first we're training a classic regular hybrid gradient boosting machine learning model using the unified classification model. We're not looking at the parameters, but that's how we would typically do that. Train a model, and data scientists would exercise this thoroughly to come up with the best possible model. And we could first and foremost then investigate how good is the model using the score function and looking at predictions, seeing, for example, the explainability, the reason code for the individual scores or predicted value, what contributed to the decisions, and a unified report here would show us the different statistics, like, for example, for the test data, the scoring statistics, that the precision or recall is good or should be improved. And finally, for evaluating now the fairness across the age groups, I've prepared here a visualization using a FairML package, which basically shows us now if we are looking at the false positive rate, that it's quite different between the age groups A and B. So there's a significant number of customers unfairly qualified as their loan, their credit would be defaulting in age group A compared to age group B. And that's something which is unfair, and we want to mitigate it. And that's why we are taking the same parameterization of the hybrid gradient boosting tree model here. So taking the same parameters and now making use of the FairML classification method. Using the fair constraints, we want to optimize for a false positive rate parity. So we want the harm, basically the false decision, to be the same across both age groups. There could be multiple features now here applied, which we want to be sensitive for, but in our data set, we only have this age group. It could be gender and minority, etc. Could be added here, so, but for simplification, we're just using here the age group. And now I'm training this model, and internally now, again, the hybrid gradient boosting classifier is used, and on top of that, the FairML algorithm adds this evaluation of the different groups, and therefore it just takes a little bit longer. And now we can again look into the results. So we can predict with our FairML model, as we can see here. And if we go again into the visualization, we now see for what we want to optimize for regarding fairness, that the false positive rate is somehow more equal than before. And specifically, I think we have cut it down from 27 or 0.27 to more or less 0.2 or 25 for that age group. So we have an improved model, which is still a little bit unfair, but we have optimized it to be less unfair regarding the age group. And that is, again, just as a final report, would also be here shown by this graph here. And this is what I wanted to show to you. And as a summary of the enhancements in the AI machine learning area. And with that, I would like to hand over to Shabana for more multi-model updates. Thank you.
Thank you, Christoph. And hello again, everyone. So for the multi-model section in this quarter, we have a very exciting and interesting update. Like you all know that we have the spatial engine, the graph engine, the JSON document store engine, and SAP HANA Cloud. All of them can be combined together for your data analysis and real world problem solving scenarios. We know it all. So just making it more and more efficient, now we have the ability to combine the graph and JSON document store aspects in much more technical way. Now we will be able to perform graph processing on JSON document store collections, meaning you can now build graph workspace on a JSON store collection and perform relationship or network analysis on the graph data that is stored in a JSON format. So how does this work? To make this possible, the data structures that are required are created step by step. This way, every artifact needed has its dedicated statement. We already know that we can create JSON collections using create collection statements. And then on top of it, we would need the hash index and the adjacency index, which is created. And in the end, we will just have this adjacency index connect to the graph workspace. So we talked about creating adjacency index now, so which is a new one since we are creating graph workspace on JSON collections. What does this adjacency index mean and why are they even introduced? Just to understand, SAP HANA JSON document store has no prior definition of which field exists or their data type. And also they could be sometimes very deeply nested. And the graph script on the other hand, is very different. It is statically typed, meaning that the type associated with each and every single variable must be known beforehand. As a result, if a field is accessed within GraphScript, a type needs to be provided all the time. So this type that I'm talking about could be a vertex or an edge. And for this sake, to define graph on a collection, an adjacency index must be defined first. The adjacency index here specifies the names of the type, the ID, the source, and the target fields. The graph workspace definition would then just make a simple reference to this adjacency index that we would create in the beginning. That is all technical things, and we will move on now with a quick demo of just understanding how this all works. Let me switch over to my demo screen for that. Great. So for that purpose, I will be creating a collection first, which is a JSON collection. And then I also have the hash index and the adjacency index, which is defining the type, source, and the target. And further, so let me just create all of this at once. And then moving forward, I'll be inserting certain values inside my JSON document collection. So these are data that looks more like a graph data. And then finally, we will be creating the graph workspace on top of the adjacency index that I just defined in the beginning. I'm going to run the statement, and we have the graph workspace created completely. So we can also have a look at this graph workspace just by having a look at what we have created, which is common, just like how we do all the time. We can just get into this and open our graph workspace, and we can see that we have the respective edge tables and the vertex table details defined. So that is a very simple demo on how these graph workspaces could be now created just on top of your JSON collections. Moving on. So we will have a quick look at the benefits and few of the use cases. Starting off with benefits, like we already discussed, it will allow you to analyze the network like the graph data that is stored in the form of JSON document, a collection in our case. And it is definitely an extension of our unified data management capabilities, as it is exhibiting and supporting the interoperability between the multi-model engines. So no need to like earlier times, no need to have a JSON document and then convert it into a vertex table and then into an edge table and then build a graph workspace on top. So we are cutting down on all of these efforts. We are just going to use this new feature, which makes it easier. You directly perform GraphScript analysis on top of your JSON document itself by defining the graph workspace. And once you have the graph workspace, it becomes much more easier to start using the graph functions on top of it. And just talking about the use cases, I have mentioned few of these already while we have talked about graph analysis in the past. So the graph engine, we know, can effectively analyze social networks, which reveals patterns, communities, and finding influential individuals in the network. So by extracting the relationship and attributes from a JSON data representing user profiles or interactions, the graph engine can identify key players or uncover hidden groups or track the spread of information or some influence. And also the graph engine, as we know, can power recommendation systems by analyzing user preferences and social connections and finding out the product similarities that are represented in JSON data. So by identifying these patterns and connections, graph scripts can recommend the relevant products, the content or connections to the users, because most of the time we have noticed that these product catalogs are in the JSON format, and this feature would make it much more simpler to analyze in that case. And finally, we all know that graph engine play a very good role in detecting fraudulent activities and identifying anomalies in complex systems. So by analyzing the patterns and the relationships in JSON data, which has like information about transactions or some financial movements or network traffic data. So here the graph script can flag the suspicious behavior, find out potential frauds and deviations from the normal patterns. So yeah, I think with that now I will hand it over to Tom. Thank you.
Thank you, Shabana. Let me share my screen. If you've worked with BTP for some time, you'll be familiar with Cloud Foundry. It's what we call a runtime environment, and that's where you deploy and run microservice-based applications and services. And for a long time, BTP was almost synonymous with Cloud Foundry. But of course, Cloud Foundry is not the only runtime that's there in BTP. In more recent years, Kubernetes has become a widely used system for managing container-based applications, and SAP Kima is a Kubernetes environment that's extended to integrate into BTP. And with this release, we've been building out our multi-environment support, but with this release, you can provision HANA Cloud databases, HANA and HDL, in Kima and in Kubernetes. Now, I know that this topic of runtime environments is confusing. So in this segment, what I want to do is give you a quick overview of BTP runtime environments and how they relate to HANA Cloud, then look at Kima and Kubernetes, and finally just give you a sketch of how you actually do the provisioning. So here's the HANA Cloud landscape, and that's a set of Kubernetes clusters in any data center. And we do sometimes talk of provisioning databases in Cloud Foundry or in Kima and so on. But no matter what runtime you use, the HANA and HDL databases, they're always running in this same landscape. However, access to them from BTP is through a runtime environment, from a runtime environment. So for years, you've been able to provision and manage HANA Cloud from Cloud Foundry. And I'm sure many of us think this is just how BTP works. For years, the tools ran as Cloud Foundry applications, and when you provision a HANA Cloud database with those tools or with CF, CLI, you do so with Cloud Foundry credentials, and so it is in, if you like, a Cloud Foundry space. But last year, we brought the ability to provision and manage databases with the BTP CLI, and authorizations for this, they're granted as sub-account role collections, and it appears in BTP Cockpit as the environment other, because there's no actual application environment here. We think of it as being in the sub-account. And with this release, anyone who wants to use Kima to run applications can integrate HANA Cloud provisioning from the same place. And beyond that, some customers, SAP customers, already have their own Kubernetes landscapes outside of BTP, and they may want to use HANA Cloud as a database or a data source for applications running there. So they too can manage your HANA Cloud instances and your databases with the same tools you use to manage the rest of your landscape. So I want to emphasize that Cloud Foundry is not going away. If you currently run your databases in Cloud Foundry and it's working for you, you keep doing that. But what we're talking about here is introducing support for these Kima Kubernetes environments. So let's say a little more about those two. So Kubernetes is, as it says here, it's a system for automating management of containerized applications. Some SAP customers will already have Kubernetes landscapes outside BTP, or maybe using Kima in it. Kima is basically Kubernetes integrated into BTP, so there's some extensions to provide things like integration with BTP Cockpit and with other BTP features. And if you're using either of these to run applications and you want a database for those applications, whether it's a data source for dashboards or an operational database for transaction processing, you could manage it yourself, within that landscape, or you could use a managed database service like HANA Cloud, obviously. And in this case, even though the database itself isn't running in your landscape, you probably want to manage it from the same tools that you use to manage your applications that are running in your Kubernetes landscape. And so that's what we offer now. So if you're using kubectl or Helm to manage your HANA Cloud resources as well as everything else that's going on in your Kubernetes environment, it makes life easier. And if you're using Schema, well, if you're just using Kubernetes runtime environment, there's some extra setup to do to use the SAP BTP service operator. If you're using Schema, all that's set up for you. And so you can just go ahead and use kube control straight from there. So that's what you want to do. You want your Kubernetes or Schema user, and you want to manage HANA Cloud databases along with the rest of your environment. So let's just say a little bit about the workflow. I won't go through it in detail. There are blog posts, there's documentation for all that, but let's just give an idea. So all these cases, anything you do in a Kubernetes environment is always set up with a YAML file, and it's the same kind of parameters, however, that we've seen for Cloud Foundry and for others. So you need a YAML file that specifies your database configuration, the amount of memory, and so on. And here it is in red, and you provision that with a kube control apply command specifying your YAML file. If you want to do that, so you'll notice one thing here. You don't really want to be putting system passwords, for example, in these YAML files and storing them in text files in your configuration management. It's just not secure. So what we've got here is the final line of this red segment, generate system password true. It's like, okay, so it's going to generate the dbadmin password for you. Well, how do you get that? Well, the next thing you do, moving on too quickly, is to create a service binding. So the dark blue here on the left, we've got a YAML file to do that, binding.yaml. You use kube control, apply binding.yaml, and that'll give you a password. It'll generate a password. And in Kubernetes, all these kind of passwords, credentials, secrets, they're always held as what's called a secret. So you use kube control on the right-hand side here, the third one down, to get a secret. And then I've just done some extra scripting here to strip out the password from that, and so it's printed out as RGQ1 and so on. So that's just a sketch of what we have. Let's recap before I pass it on to Shraddha for the next thing. If you're using Schema or Kubernetes, this is for you. You can manage HANA Cloud with the same kube control or Helm tools that you use to manage the other resources in your Kubernetes clusters, even though, of course, HANA Cloud isn't actually running in those clusters. Let's emphasize that Cloud Foundry remains a fully supported runtime environment, and you can look for enhancements to the multi-environment tools coming soon to enable full lifecycle management of Cloud Foundry databases. So with that, I'm going to pass it on to Shraddha. Thanks very much.
Thank you, Tom. Let me go ahead and share my screen. Yep. So today I will be discussing about some of the new features that was introduced in the database development with respect to the Visual Studio's code and with respect to BAS. Firstly, we have the wizard for HDI container creation in SAP Business Application Studio. And with respect to that, we have the service instance creation and sorry for that. And we also have the optional schema setup, and also we can make the schema as make unique in order to have the unique schema name. And also, if there is a multiple database instance in a particular space, you can also give the database ID with respect to where you want to deploy the particular HDI container. And next, we have the Database Explorer plugin in the Visual Studio Code, where you can add the HDI container as a local connection with the normal form-based mode and also via JSON. Here we can also use the existing HDI container that is already available in the BTP account and copy the JSON and add the HDI container in the Visual Studio Code. I will also show the HDI container addition with respect to in the Database Explorer as well. Next, we have another Database Explorer plugin where we can view the metadata of a view in the in the Visual Studio Code, where a new metadata dialog shows up with the information with respect to the view. And this is the next one, which is similar to addition of the HDI container with the help of JSON string in the Database Explorer. Now let's skip to the demo bit. So here I have the Business Application Studio where I can go into the command palette. And under the HANA tooling, you will find create an HDI container service instance, where you can basically give in the details like test for, and in case if you have a already a name that's existing in the BTP, it would show up with an error message saying that you cannot have another database with a similar name. So I will give with the unique name. You can optionally give the schema name of your choice, and in case if you do so, you can add the checkbox of making the schema name unique. I will go ahead and not give the schema name and let the generator generate the schema name of its own. So since this particular space have multiple database instances, I want to be particular about the database ID that I want to give in, and not rather go for a default database instance. And also I want to add that if there is multiple database instance and if you do not specify the database ID, it will give an error saying that there is multiple database instance and please configure the database ID in itself. So let me go ahead and copy the database ID and enter here, which is basically the instance ID. You will find it in the HANA Cloud Central. And this will go ahead and create the HDI shared HDI container in the BTP. And you can also view this HDI container in the sub account under the instances and subscription. If I go ahead and refresh this particular browser window, it takes a couple of seconds in order to create that as well. And that will go ahead and create a test for here. You can also create a shared dev key and also see the desired database ID, HDI user, the runtime user, the design time user, and all the details with respect to the HDI container in the shared development key. So while this is creating, I will go ahead with the next section, that is in the Visual Studio Code, how you can add the local connection to the HDI container here. So basically, you can just click on this plus icon, which will show us the form-based approach to add the HDI container. So I will select HDI container, and you can go in this approach of adding the host, user, password, HDI user, HDI password, etc. I would rather go with the input data as a JSON, which is basically you can quickly copy one of the HDI containers that you have. And for example, let me go into the shared dev key here, and I will copy the JSON here and go back to my Visual Studio Code and add the respective JSON and also give a name as test4 rather than having the entire instance ID as the name here. So I will go ahead and add that database, and you can see that it has been added, and you can see the tables or any of the artifacts with respect to that particular HDI container in your catalog browser. So continuing with this same thing, I would also want to see the metadata of a view, so which is also a new feature that is introduced in the Database Explorer plugin. I will go ahead and see the metadata with respect to the catalog service books. And let me just open something else. Yeah, so this will basically show the metadata, which consists of the column names, the the SQL data type, etc. And also this will also consist of the create statement view as well. And also you can click on open data, and which would basically give the data with respect to the view. Proceeding further, I would also like to show the addition of the database HDI container in the database explorer itself, which is similar to what we saw in the Visual Studio Code. We have selected HDI container here, and also I would go with the approach of addition of the JSON string, and I will go ahead and click on apply, which will fill in all the details. And I would like to change this name to like test1, and click on OK, which would basically add the HDI container with respect to it. And also you can explore the tables or views with respect to that particular HDI container added. So this concludes my demo, and yeah, would like to hand this over to Thomas.
Thanks a lot, Shraddha, and thanks for the deep dive into the innovations associated with basically database development, our tooling, and HDI containers. Now, wrapping this session up, I want to talk about a few further content highlights that we've been always like sharing with our release that give you a more comprehensive look into what we have introduced, apart from all the deep dives that have been provided today. So very important to mention, as always, we have a blog post which accompanies the release of SAP HANA Cloud. We are summarizing all of the highlights again, but we're also going beyond that, giving more insights into innovations which we haven't covered during the webinar. So definitely take a look at the blog post to get the most comprehensive picture. What's super important to state is also our What's New viewer for SAP HANA Cloud. It's also linked in a blog post, and it gives the very accurate update with regards to changes and enhancements introduced to SAP HANA Cloud. Next, we have the tutorials as well as the blog posts listed here on screen as well, which I already mentioned in the beginning, that give more deep dives into the specific areas that we have been rather brief on today, but definitely make use of them. All the innovations and all the resources are super helpful and valuable, and therefore I can only recommend taking a look. In addition, as always, our community tag, What's New in SAP HANA Cloud, brings you to all the relevant information. So make sure to follow that tag in order to stay up to date with SAP HANA Cloud and also stay up to date with all the, let's say, content packages that we are releasing, because that is our main source for you to basically consume such information. And last but not least, if you want to learn more about SAP HANA Cloud, about specific areas like calculation view modeling, optimization of queries, our multi-model data processing capabilities, then I can only recommend taking a look at the Open SAP courses available for SAP HANA Cloud. They are free of charge and a super great source of learning. And our product experts from the development and product management organization did their best to give most precise content for you, so you can learn more about all the capabilities provided by SAP HANA Cloud. There is much more we could say about HANA Cloud for sure, but that's it basically for this time, for this What's New in SAP HANA Cloud webinar, talking about the Q4 innovations of SAP HANA Cloud. Thanks a lot to all the speakers, to all the product experts that gave a great deep dive into specific innovations introduced into SAP HANA Cloud with the Q4 release. Thanks a lot to all of you for joining our webcast. Have a nice holiday season coming up, and see you soon again. Thank you.